design one together. So before we get to that, I would like to very briefly talk about operational amplifiers, as I mentioned yesterday. I was thinking, and I won't go too deep into the details, just to give you an idea of how it works, then you can read further on to understand for yourself, yeah? Because we don't have much time. Okay, so we have, basically, operational amplifiers are key components in electronics, and there are millions of applications that use those devices. Yeah, you can find them anywhere. So, what it is, it's a device that has a supply voltage supply, ground, two inputs. One of them is the non-inverting input, the other one is the inverting input. So, what it actually does is, it has a coefficient of amplification, gain, yeah, which is really big, which is a really big number in most of the operational amplifiers. It can be like a number 10⁴, 10 to the power of 5. There is this idealization of operational amplifier behavior, which says that it has two golden rules. One of them, it says, well, this is formulated differently, so I will say one way, that the gain is infinite. And the second one is that the inputs consume no power. So they have a very high input impedance, yeah? So we will write that ion plus and ion minus, they are tuned to 0. No input power. What they do is, when you apply voltage to these 2 coins, the voltage difference, basically, it is multiplied by the gain, and you have an output, voltage out. Let me draw this like this. If we connect this pin to the ground and apply voltage here, here's what is being done. Because we don't need an amplification to be infinite or very big. Yes, because, for example, we want to amplify 0.1 volts to be 1 volt, because our device doesn't sense this. What we do, we can define the gain. The gain is defined like this. You put a resistor here, you put another resistor here. This is R1, this is R2. So if this is connected to ground, we have voltage in and voltage out. So basically, voltage out equals R1 divided by R2 times voltage in. So this limits the gain to whatever you choose it to be. Yeah? Why do you think it's important that these pins, the input pins, don't consume current? Any ideas? Why?
It's because when you amplify it,
Sorry?
when you amplify at the other end, it won't be in the right ratio or something?
No, because if we have a current flow here, if we have like very low voltage here, like 0.05 for example, and there's current, it will get even lower, and it will affect the whole system. So we want to have the potential we have here. So maximum input resistance will, just not get this up. Okay. So there are the inverting type, non-inverting type, and I would just like you to read about this, so we can then discuss the comparator and how it works. And there are millions of applications on this. You can make yourself an amplifier for the microphone and for, I don't know, small voltages, etc. When we drew this yesterday on the board, we drew this in the regime of comparator, not an operational amplifier. So what it did, we just put a reference voltage here. So what it does, if we have a voltage of some kind here and then another one here, the difference will be multiplied by the gain, and if one is more than the other, we will have positive output. If it's negative, we'll have negative output. So it all comes from this theory. Yeah, there are no like other things. Okay. So just if you have time, open something and read about operational amplifiers a bit. Before I show you some simulations on the computer, how to test your circuits before actually making them, maybe it's a good idea to revise what we did yesterday and maybe create a circuit board of line tracking robot together. Yes, by blocks. So the circuit board has different blocks: power supply, sensors block, microcontroller block, motors block. Yeah, so I'm listening to your suggestions, and let's put this on board. We have quite a big board here, so I'm listening. What do we start with? Yeah.
We might not necessarily want to start with this, but we're going to need the H bridge to control the motors.
Great. We have the H bridge. Let's draw the H bridge. I'm not drawing the actual microchip, but I'm drawing the schematic view, so you can then connect to any other H bridge. Motor 1, motor 2. Now let's name these contacts. So later on we can connect this to the other part. Yeah? Oh yeah, we have the supply voltage. We have the ground. This one would be, okay, let's run left and right, so it's easier to read. Yeah? So we will have motor left 1, left 2, left enable. We will have right 1, right 2, right enable. Okay, so this part is done. We have our voltage for the H bridge, and now let's go to the other parts. What other parts do we have in this circuit? Sorry?
Power source.
Power source. Let's draw the power source here. We have the stabilizer, regulator, or you can call it any way. We have a capacitor here. Let's say 100. We have another one here. Okay. In here we will have our plus. Let's say we supply the circuit board with 12 volts, yeah, the voltage that we're going to use to control the motor. So let's just write VS, voltage supply voltage. Let's say 1000 microfarads, let's say 100 amps, and the same 100 here. Okay, so we have this part ready as well. The capacitors that I put plus sign on, it means they are electrolytic. They have a polarity. You can't connect it to this one. Yeah? The ones that I don't, it means they are ceramic. Okay. And we have the point of plus 5 volts here, which is regulated. No matter how we change this voltage, we have a regular 5 volts outputs here. Okay. We're done with the supply voltage as well. What else do we need?
Sensor block. So
Sensor block. Great. Let's do the sensor block part. First of all, let's think of how many sensors do we need for this. Are we making a robot that, yeah? Are you saying anything? Let's think of the task itself, except following the line. Should it have like 90-degree turns or something, so we sense the turn as well? Or are we just gonna do like a line and just follow it without any sharp turns?
90-degree turns.
Yeah, what?
Like more than 90-degree turns.
90-degree turns.
Probably.
Alright. In that case, what I would do, I would build the robot in a way. Let's say this is a robot. These are the wheels. I would put two sensors in the front. So this is the line. The sensors will be like this. And because I want the robot to rotate on the 90-degree turn, I will put 4 sensors or maybe 3 sensors here. I'll tell you why. Because the axis on which it's going to rotate is this. Yeah. So if we have a turn like this, when the robot senses a turn, in this case, it would mean another one here and another one here. It drives until the middle part is here. Yeah? Until these sensors get on this. So it will be something like this. And then it can return and like point its nose to another line and just continue driving from here. So for the beginning, I say 1, 2, 3, 4, 5, 6, 7 sensors. Yeah. Okay, I'll write the names of the microchips as well, so you can see here. Okay, now let's get to the sensors part. Let's draw the diagram for one sensor, then we can do for another 7, yeah? Not to waste time. So this will be our comparator. This will be our potentiometer, which will go to power line. If you have any questions while I'm speaking, please don't leave it for later, just ask it then. And this would, let's name it, okay, let's do it like this. Let's do it, for example, an LED here. This. And bring this with another resistor to just limit the current to S1. Yeah. S1 is just one of the ports of the microcontroller, which we have 7 of them, 7 or 8 of them. Okay, so this is our VS, this is the ground, this is our comparator. What we do here is we have a sensor which has a transistor like this. I will draw it, then we'll discuss how it works. Kilos, let's say. This can be 270 ohms. This can be 1 kilo. This can be 20 kilos. And we will have our photodiode LED. The 300 ohm battery. Let me see if I've done everything correctly. volts here. And that's it. This is the schematic for one sensor to communicate with the microcontroller. How does it work? Okay, we have an LED that's always on, as you can see, because the current flows from plus to minus. Yeah. Actually, it goes from minus to plus, but we consider it plus to minus, as you know. That's how it is. So this is always on. We have a small sensor which is transmitting infrared light, and we have another part which is the phototransistor, which is attached to the sensor. So it's a sensor like this, which has a LED, transmitter LED, and the receiver one. So when we approach it to a surface which is white, obviously it has better reflection. So the light here is more than if we approached it to a surface with a darker surface. So the light here changes. When it changes, the current from the transistor differs. When it differs, we have a voltage drop here. The voltage at this point changes as well. Yeah. So, and we have a threshold here. This is a constant number, yeah, a voltage, for example, it can be 2.5 or 2.7, anything between 0 and 5. So we will have our threshold here, and this point will change depending on the light. We should set the threshold in a way that from the distance that we want. For example, this is the robot. This is the sensor. We have the light coming down and going back up. This is the distance between the sensor and the ground. So we put the robot on the ground and set this threshold to give us the right. And with this LED, we can see if it's white or black. Is this part clear? Why? Because if this point goes more than this lights. So we actually don't have to like go into the program and see what this thing does, I mean, what the input is. We just visually just rotate the screwdriver on this potentiometer and see if this is lighting or dimming, or actually it won't dim, it will either go up or down. And we can set the white and the black. So this is the circuit for one sensor, one infrared sensor. The sensor will be this part, it's called CNY70. And for this you can use LM324 as I said yesterday. By the way, LM324 has 4 comparators inside, so you can put 2 comparators in total for building this robot. You will have 8 inputs and 8 outputs. Okay, we have the sensors part. What else do we need? Any extra fancy things we want to add to the robot? Huh? GPS? We have the line. Well, not yet. Not yet. Yeah.
You need your microcontroller block as well.
Yeah, obviously. And so we will draw the microcontroller. This is the key, these are the pins. Actually, what I'll do, I won't draw it as the chip itself, so I'll draw it again schematically. So I'll just draw a box like this, which has a VCC that is connected to 5 volts, which has a ground. It has ports from S1, S2, etc. We have 7, yeah? S7. These are the sensors that connect to here.